Okay, so now in our second rule, the only change is that in earlier we had both m and n as positive, but over here probably this n might come as negative. So what will happen when one may come as negative? So we may want to put it this way that okay, I'll take again this base as common. So I'll write a, let me write it properly. So I'll write common base as a, and now I want to add these two, that is mn minus n. So again I may want to put a bracket, and let's put n plus, and then in small bracket I may have minus n. And as per my previous knowledge of integers, I do know that plus and minus, when it comes, they will give me a value which is negative. So over here, yes, I do understand that this would become a raised to n minus n. So we know when, okay, let's take example as well. So this would be 2 raised to 3, let's say, and it's getting multiplied with 2 raised to 2. So this could be, let's say, it could be, oh, we have minus actually, so this could be 2 raised to 3 and minus 2, and this would be simply 3 minus 2 we know is 1, so it could be 2 raised to 1. So this is one extension of the same rule. Now what if instead of this multiply we get some change, and that change could be, let's say, if I get 2 raised to 3 and I get a division sign over here and I get 2 raised to 2. So the rule over here is like a raised to n divided by a raised to n is equal to, you take the base as common, so write a, and m minus n would get subtracted away. So over here what should happen is that I'll take it as common base, so this would be 2, and in powers, instead of addition now, which we used to do in multiplication, we'll put a bracket probably to make things easy, and 3 minus 2. Why? Because we are doing division over here. So this would be like 2 raised to 3 minus 2, how much? Yes, 1. So this would be 2 raised to 1, and it's equal to 2. Now on using my knowledge over here that when common base multiply we add, when common base divide we subtract, using this little bit of knowledge, let's try to go back to our story. And our story says that okay, this light was coming into school, and in school what do? Yes, we study. So I have this book, and what is the thickness of the book? Oh, so this seems to be 20 mm. So what is 20 mm? Let's see. So I'll make some space over here. And I will write, let's say, my book thickness is equal to 20 mm. Now as we know, the first m signifies what? Exactly, the first signifies milli. Over here. So probably there are multiple ways of solving, but probably what I can do over here is I would want to put this way that okay, this is 2 times 10, and milli we know is 1 upon 1000, and over here we put meters, and meters is this m actually. So if it's 20 millimeters, I'm splitting into 2 into 10, and for milli I'm dividing by 1000 because that's what we do with milli, and over here this 0 and 0 might cancel, and guess what is remaining? This is 2 times 1 upon 100, and then we get meter. Now what is it exactly? So people say, okay sir, it is 2 upon 100, so 0.02 meters. Well no, I'm asking that what unit could this be? We know the unit is meters, but can we now at this stage identify modifier, like let's say we were discussing milli was 1000, 1 upon 1000, we know. So which modifier could be 1 upon 100? Oh yes, I know, we learned 1 upon 100 is something called centi. So instead of 1 upon 100, I write centi, and from over here I write meters. So we know this is equal to 2 meters. Now what a wonderful conversion over here, just with the identification of prefix notation. So what we do, when we get 1 upon 100, we can put a centi, and when we have 1 upon 1000 or a milli, we can change things accordingly. So one thing to understand, that you need not understand the formulas, you need not remember the formula, just understand the concepts over here what we're discussing. Now we do have thickness of a paper as well. Now if I have this paper or any other paper, they're very thin. Now let's say, what can be thickness of an ideal paper which we use? So let's try to look into that and delete this over here. And the thickness which is mentioned is 0.0. So book thickness, I'll just cancel and I'll write paper thickness. The paper thickness is 0.0016 centimeters. Now, what if I want to change that into meters? So what I'll do is, I'll write it in a way like 0.0016. And what was C? Yes, exactly. So C is 1 upon 100, and this finally I get meters. Now one thing to understand, that can we also play with exponents? Yes, we can. Let me tell you how. So what I'll do is, in order to change this into standard form, there's something called standard form in exponents. Let's try to convert into that. So first I'll try to change this part over here. So 0.0016 I know is 16 upon how many decimal places actually? So it's 1, 2, 3, 4. So it will be divided by 10,000. Why? Because if you divide by 10,000, you can go back like 1 place, 2 place, 3 and 4. So 0.0016 essentially is 16 upon 10,000. And guess what? We also have this brother over here, which is 1 upon 100. So how can I write this into exponents? So over here, 16 into 1 is 1. And now what will happen? 4 zeros will add up to 2 zeros. So what I can write is 1 and 1, 2, 3, 4, 5, 6. And how can I simplify it further? I can write it 16 over 10 raised to what? Exactly. I'll just count number of zeros. 1, 2, 3, 4, 5, 6. It's 10 raised to 6. It's 10 raised to 6. So basically this means that 10 is multiplying itself how many times? 6 times. Yes. So 1, 2, 3, 4 and 5 and 6. So when it multiplies 6 times, 1, 2, 3, 4, 5, 6, we get 10 raised to 6. Now, is this the standard form? Well, to convert into standard form, one final thing is that I'll take this from below to above. So the base would be same, and it could be written as 10 raised to, but what should I write? Should I write 6? Well, no, it would be minus 6. Why? Because the sign was over here, nothing but plus, and that plus shifts to minus when you take. So this will be kind of a standard form, and sometimes it's also written like 1.6. So if we divide by 10, then one number would increase. So it would be 1.6 into 10 raised to minus 7. Now, these are a few basics about exponents, but we also have a very important thing to discuss, that what is the height of Mount Everest? And why I'm saying important, that probably if I'll go in excitement and I'm not able to climb it, so you know, it would be very funny. So I should know what is the height at least, yeah. And yes, I did study in school that the height is 8,849 meters. Oh, I think I can't do it. Probably you can. And the phone which we are using, can you imagine? It has very small wires in its chips. What could be that diameter? And that as well is very astonishing. It is like 0.00003. So there are how many zeros? 1, 2, 3, 4, 5 zeros and a 3, and it's all in decimals. Now we have crazy values and the technology is advancing. So what I'll try to indicate over here, that as and when we grow, we need more of an exponents. And now let's try to discuss a few more rules and we're good to close. So let's try to rub it and make some space. And one rule which I really want to discuss before we close is that any number like a raised to 0, what should be its value? Now this proof is very dear to my heart, and before we close, I really want to discuss it. Now this could be any number. Let's take the number as 2. So if I have 2 raised to 0, what could be its value? That's the question. So I'll imagine, okay, I studied that if I have like 2 divided by 2, yeah, 2 by 2, and the powers, if it doesn't have any power, so it could be 1 and 1 this way. And I also know the rule we have a raised to m divided by a raised to n is equal to a raised to m minus n. It could be also written this way, by the way, a raised to m by a raised to n. So this is very similar over here, that I have a and raised to m and raised to n. So this could be 2 I'll take as common, like over here you need a raised to m minus n. So 2 I'll take common and put 2 over here, and this will become my m. And this one, when it shifts, we just did it a minute back, when it shifts, it was positive, it shifts and becomes negative. So it would be either through division formula, which you know, or the way I told, anyways, it has to subtract. So when it subtracts, it would give me finally 2 raised to 0. And what would actually 2 by 2 be? So if I take, I know 2 by 2 is essentially 2 ones are 2, 2 ones are 2. So we know 1 is equal to 2 raised to 0, or 2 raised to 0 is equal to 1. Now this you can do actually for any number, that you divide any two numbers having a common base, you play with the exponents, and yes. So when you do a little bit of calculations, obviously a lot of confidence would be increased in you. So let's see a couple of more rules to get more clarity. And we do have one of the rules over here, and this rule is like a raised to m and to the exponent n, a raised to m raised to the exponent n. This is actually equal to a raised to mn. Now, can we also verify this rule? And it's very important to verify than just mugging up the formulas and rules. So let me take another example, and I have this favorite number which I have like 2. So 2 raised to, let's say I'm doing 2 raised to 2, and it is, even if I take 1, this should work, I think. So it is 2 raised to 1, and the n part, if I'm taking m as 1 and I'm taking n as 2, so what should happen over here? According to this rule, actually this should be 2 raised to 1 times this 2. So let's see, if I'll solve this, what happens? If I solve this, what happens? So this becomes my left hand side, which is LHS, and this becomes my right hand side, which is RHS. So this becomes like 2, because we know 2 raised to 1 is also 2, and this will be having a square. And if I solve this further, this would be 2 times 2, as we studied right at the start, and finally I should have 0 over here. Now I'll just put an implied sign over here, because I also have an equality sign, with which we should not forget. Now according to this rule, what should happen? That 1 and 2 will multiply. So what will happen? It would be 2 raised to 1 times 2 is 2, and again the same thing, 2 times 2, and it's equal to 4. So yes, we have verified this rule. So one rule is verified, one step taken, and let's go to another. And this must be the strategy in life, that if you think things are getting difficult, take one step at a time, and things will just get clear for you. So let's try to rub it and go to the next rule. Just a few more rules, and the other rule is actually that a raised to m times b raised to m, it's equal to ab to the power n. So what they're doing is they're taking this inside a times b and to the power whole to the power or to the exponent n. Now what happens over here? Let's take the example of again 2 raised to 1. So now a is 2, but b could be something else. So let's take it as 3 raised to 2. So it's like a raised to 1 times 3 raised to 2. It should be according to this rule. A, yeah. And over here, yes, we do know that n has got to be same. So probably, yeah, I do need to make them same. So if I take this as 2, I'll have to take this exponent as 2. So let's revise. I'm taking a as different, I'm taking b as different, but the m part is the same as per this rule, a raised to m into b raised to m. So both have got to be same. And now we are saying that these will multiply a and b, but this exponent will go to the whole power, let's say, as we say, to the whole, raised to whole. So what it goes over here, if we solve this individually, 2 raised to 2, we know it is 2 times 2, and we have 3 raised to 2, we know 3 times 3, which essentially would be 4 times 9, and it should be 36. So if I imply this, and if I try to balance it with the equality, so let's see, I'm getting 2 times 3, 6, and this is 6 raised to 2, and this would be 6 times 6, because the exponent is saying that we need to keep it twice and then multiply, and 6 times 6 is 36. And guess what? Both left hand side and RHS are equal, so hence this rule is verified. And now we have this last rule over here. So let's try to check if we can verify. Even if we cannot, don't worry, we just need to keep working and strive for what we want. So do keep working, and I'm with you in all the struggle, don't worry. So I'm going to check if we can actually verify this rule. And this rule is saying that a raised to m over b raised to again n, this must be equal to a by b to the whole exponent m. Let me confirm. It's a by b, sorry, a raised to m by b raised to m is equal to a by b whole raised to m. So let's say I'm taking value that let a be 4, yeah, and b be 2, so 2 different numbers I'm getting. But over here, let my n part, what should I take? Let them be like 2, so I'm putting over 2, I'm putting them 2, and on the right hand side this would be again a by b, which would be nothing but 4 by 2, and the m part, since I'm taking 2 over here, I should take here the whole raised to 2. So now let's try to sort them individually. So it implies that this should, the numerator should come as 4 times 4 divided by 2 times 2 as per the exponent. The right hand side will be 2 ones are 2, 2 twos are 4, as 4 by 2 we know is 2. So this would be 2 raised to 2, and when we solve over here, we get 2 ones are 2, 2 twos are 4, 2 ones are 2, 2 twos are 4. So essentially we get on the left hand side 2 times 2. So this would be 2 times 2 over 1 times 1. You say where the 1 came from? Well, it's over here right in front of us. Yeah, and this would be equal to 2 raised to 2. And what is 2 raised to 2? Again, 2 times 2. And at the end, when you solve this, you get 4 by 1 is equal to 4, and obviously 4 by 1 we know is 4, so we say okay, at the end we get 4 is equal to 4. Both left hand side and RHS, which is right hand side, are equal. So now a lot of learning, and as we know, we started with having a basic facts in our life, and then some rules, and then some stories and a lot of calculation. But let's stop over here, because sometimes in the struggle of daily life, when we are running, we need some time to stop, to reflect, and to relax. Why? To recharge your batteries and then come up to your best of your ability the next day. Thank you, thanks, sir, and have a nice day.